Hello all. In today's session, we'll talk about multi-layer perceptron model. In the previous session, we have seen a single perceptron, which is nothing but a single neuron in a neural network, which works great with simple data sets, that is the data sets which are linearly separable, that is the data sets which are easily separated by a straight line. Now, what if the data set is complex? A straight line will not be sufficient to divide the dataset when it is complex. So in such cases, we make use of multi-layer perceptron model where neural networks show their full potential. So what happens when we have complex dataset is we make use of multi-layer perceptron model, also called as MLP model. Now, why do you call it as multi-layer perceptron? Perceptron itself represents a neuron. When I say multi-layer perceptron, then it means that I have n number of layers and n number of neurons. This is my single perceptron model, a single neuron with input and output layer. When I say multi-layer, I have one layer, neurons stacked one over the other. Second hidden layer, neurons stacked one over the other. This is my output layer and this is my input layer. This is first hidden layer. This is my second hidden layer. I have inputs connected. Now you call this type of connection or this type of multi-layer neurons as multi-layer perceptron model, where I have n number of neurons stacked one over the other in n number of layers. Now what kind of data set we are talking about is, to the left side of a two-dimensional figure you can see that this is a linearly separable data, that is my data can be easily divided or split using a single straight line. Such type of data is called as linear data, and to solve such linear data we make use of single perceptron model. What if my data is non-linear? In such cases, we make use of multi-layer perceptron models. Now, what kind of data set is non-linear data is? A single line will not be enough to split my data set. I need many single lines to split my data set. Such kind of data set is called as nonlinear data, and to solve nonlinear data, a single perceptron will not be enough. So we make use of n number of perceptrons called as multi-layer perceptron model. So this is the difference between linear dataset and non-linear dataset. The dataset that can be split with a single straight line is linear dataset, and the dataset that cannot be split with a single straight line, that is, we need more than one line to form a shape that splits the data, is a non-linear dataset. Now, as we have already learnt that for a non-linear dataset, we need more than one line. That means we need to come up with an architecture that uses n number of neurons in our neural networks. So let's look at the example here in the figure. One point you need to remember that a perceptron is a linear function that produces a straight line. So to fit this data, we need 3 perceptrons to create a triangle-like structure. So each line will be generated by one perceptron, that is one neuron. So here we are making use of 3 neurons which are stacked together in one layer called as hidden layer. Now why do you call it as hidden layer? Because this is the layer which we don't see or control. We just feed the input feature to the input layer and see the output coming from the output layer. This layer we don't see or control, hence you call it as a hidden layer. So here I am making use of 3 different neurons which generate 3 different lines to split or form a triangle-like shape to split the dark dots. Next, let us look into the multi-layer perceptron architecture. You can see here that it has 3 parts: input layer, hidden layer with n number of neurons stacked one over the other, and the third part is the output layer. A very common neural network architecture is to stack the neurons in the layers on top of each other called as hidden layers. Each layer has n number of neurons. Layers are connected to each other by weight. So I have weights corresponding to each input node. This leads to multi-layer perceptron architecture. So I have n number of layers with n number of neurons stacked one over the other. So these are the main components of the artificial neural network or multi-layer perceptron model what we have seen in the previous slide. We have input layer which contains feature vectors. We have hidden layers where the neurons are stacked on top of each other. And why do you call it as hidden layers? I already told, because this is the layer which we don't see or control the input going into these layers. All we do is just feed the input vector to the input layer and see what kind of output coming from the output layer. And the third component is the weight connections, which are also called as connecting edges or connecting nodes. These are the weights, numerical values which are assigned to each connection between the nodes. Coming to the output layer, this output layer is controlled by the type of activation function what we are using, and the activation function what we have already seen is step, which generates two kind of outputs, 1 and 0. So depending upon the type of activation function we are using, this output will be generated. So in this output I can have numerical values also. I can either have numerical values when we talk about regression problems, that is predicting the price of a house, predicting the age or predicting the salary, or I can have probabilities also, a set of probabilities when I solve classification problems like classifying whether that person will be placed or not depending upon his age and experience, or whether a student will pass or fail depending upon his previous marks. All these come under classification problems. So output layer has either numerical data or set of probabilities. Now we can also call these multi-layer perceptron network as fully connected layer, because as we look into the diagram we can see that I have input layer, I have two hidden layers and one output layers. Now what you see here is the first node or first neuron of my first hidden layer is connected to all the nodes of the previous layer. Similarly, the second node, third node and so on. Such network is called as fully connected network. That is, each node in a layer is connected to all the nodes of the previous layer. Hence, this network, which is also called as a multi-layer perceptron model, can also be called as a fully connected network. Now, how does this multi-layer perceptron work? You can see that I have input layer, I have two hidden layers and output layer. The input node represents features of the dataset that we have extracted. Next, each input node passes the vector input value to the hidden layer with some weight. Now in hidden layer, what will it do? It performs weighted sum as well as applies the activation function onto that weighted sum. Here I have, for example, this is WA and this is WB. Then whatever output is generated here will be multiplied by WB and is applied to the second hidden layer. Similarly, it performs the same function, weighted sum, and apply the activation function and generates the outputs here. So the activation function is used in the hidden layers to identify the active nodes. The output is passed to the output layer, and at the output it will calculate the difference between the true value and predicted value, which gives you the error. And error is of two types. I can say that mean square error is calculated when we talk about regression problems, and cross entropy when we talk about classification problems. So the model uses, now when the error is found to be as high, to reduce this error, the model will back propagate, updating all the weight values, and then repeat the process of forward pass. So first what we have done, we have forward passed, calculated the error. If the error is high, we have back propagated to update the weights here, that is the weight values are changed. Once all the weights have been updated, again I try to calculate the error here, which is nothing but called as back propagation algorithm, that we will do it in the next session. These are the different hyperparameters that we have discussed in the sessions. We have talked about the number of hidden layers. We can have as many layers as we want with as many neurons as we want. The general idea behind that is, the more neurons you have, the better will be the network learning ability. But if we have too many neurons, then it will lead to overfitting. So what we do is we'll start with small network, find its performance and increase the number of layers. Coming to the second hyperparameter, which is the activation function, which is of many types. The type what we have learned till now is step activation function. The remaining activation functions will be studied in the next session. This activation function will find the active nodes present in the hidden layer. Coming to the error function, this error function will give you the measure how far the network's prediction is from the true value. Coming to the next parameter, hyperparameter called as optimizer, it will find the optimum weight to reduce the loss function. Batch size is nothing but the number of subsamples which are given to the network. Epochs nothing but iterations. Learning rate is one of the optimizer parameter that we tune to reduce the error or loss function. So this is the end of today's session. In the next session, we'll talk about the different types of activation functions used in neural networks. Thank you.